Chairman Maloney, Ranking Member Gibbs, and members of the committee, thank you for the invitation to speak today. Ocean shipping has the most energy-efficient way to move cargo long distances and has the lowest carbon footprint per unit shipped of any mode of transportation. Ships use very large diesel engines to move those mountains of cargo. Think 80,000 horsepower engines with great big cylinder heads. And that creates greenhouse gases and other pollutants coming out of the exhaust. Shipping generates 2 to 3% of all man-made greenhouse gases. Since 2008, Maersk has reduced our greenhouse gas and other emissions by 42% per container moved. 42% since 2008. And I might mention that your colleague, Congressman Lowenthal, has been with us encouraging and sometimes pushing us all the way since about 2006 on this. Now, our customers and other stakeholders are now asking us to do more, to go all the way to zero carbon shipping. And a year ago, we made a commitment to do just that, to achieve zero carbon shipping by 2050. Now, that sounds like a distant and rather fluffy goal, but the lifetime of a vessel is 20 to 25 years. So let's think through this. And we, by the way, operate 700 vessels. So to have a zero emissions for the whole fleet by 2050, that means we have to have the first commercial vessel on the water by 2030, which means that we have to order it by 2028, which means we have to have designed it by 2027, which means we've got the next 5 to 7 years to define what's going to go into that design. This is not a distant goal. This is a major transformation, and we can't do it alone. We're continuing our cutting-edge efficiency work with a goal of 60% reduction by 2030. We're already testing bio-based fuels, batteries, and other technologies, some of them actually on commercial vessels. As we speak, our first net zero carbon shipments are on a ship headed back from Singapore using a renewable biofuel blend made from used cooking oil. And we're developing new renewable fuels, including one that involves ethanol and lignin from plants and wood. But the biggest challenges ahead are not just on the ships. The land-based industries and infrastructure must be there to supply the fuels and technologies at scale, and we must do it without jeopardizing food production or forests. Economic and policy systems must also adapt to support this transformation. So what we need to make this happen, first focused R&D, which of course Mr. Butler discussed, alignment between national, state, and international goals, and the legal systems that support them. The International Maritime Organization sets the rules for international shipping and has set metrics and goals for vessel emissions. Requirements also need to be clearly written and well enforced and encourage early action but not penalize early actors. And yes, we advocate for strong enforcement, and we're doing so globally. We need a level playing field, and we count on enforcement to make that happen. Now let me give a recent example to show the importance of this. A couple of you mentioned the 2020 fuel rule, which reduced sulfur significantly. Now, most of the global fleet has started complying with that, and of course it just went into effect a couple of weeks ago, but most of us are complying with that using cleaner fuels. It's expensive, cleaner fuels. It's going to cost my company $2 billion a year. So it is very expensive. Now, we fully support the goals, and we are complying. But the temptation's probably out there for others. A vessel sailing from Asia to Europe could save close to $750,000 for one ship on one voyage by ignoring the new rule. Companies rely on good enforcement to provide the level playing field necessary for competitiveness and environmental progress. The same strong enforcement concepts will need to be fundamental components of any climate-related programs too. Ladies and gentlemen, the transformation to low or zero carbon shipping is an energy transformation, not just a vessel modification. Huge changes to both vessel and land-based infrastructures must happen to produce and distribute those new energy sources, and policies and laws must adapt to enable that change. Therefore, thank you for this opportunity to be part of the conversation.
Thank you, Dr. Kindberg. Mr. Bryn, am I saying your name correctly?
Yes, thank you.
Thank God. You may proceed, sir. Thanks.
I've gotten a lot of versions, so that you got it. Thank you. Chairman Maloney, Ranking Member Gibbs, members of the subcommittee, and my fellow panelists, good morning, and thank you for the opportunity to testify on this incredibly important topic. ABB has been an electrification and automation leader for over a century. With 147,000 global employees, 24,000 of which are here in the U.S., we are a market leader in power grids, advanced manufacturing, and electric transportation. For example, ABB has deployed over 13,000 electric vehicle fast chargers worldwide. ABB has 60 manufacturing sites in the U.S. with domestic headquarters in North Carolina and global headquarters in Switzerland. One example of ABB's marine technology is aboard the U.S. Coast Guard Great Lakes icebreaker Mackinac, where ABB provided our electric azipide propulsors and the vessel's integrated diesel-electric power system. ABB is excited to help lead the maritime industry towards zero emissions, as climate change is one of the greatest challenges of our time. ABB supports the Paris Agreement to avert the potentially devastating consequences of climate change. As a company with 9,000 technologists set to invest $23 billion in innovation through 2030, ABB urges policymakers to adopt sound and predictable climate policies to encourage innovation. Today, I'd like to cover three main points: the current state of marine technology, the opportunity to lower life cycle costs and emissions, and how the federal government can help speed adoption. Globally, the maritime industry remains dominated by diesel power, but the beginnings of a significant shift are underway. For many vessels, the first step is to electrify the propulsion system, meaning the propeller is directly powered by an electric motor. This arrangement allows for any energy sources to provide the power, from diesel or LNG generators to batteries to fuel cells. In the near term, this can help many Jones Act vessels reduce their emissions. Longer term, this makes it far easier to retrofit low-carbon technologies as they commercialize. So what zero-emission solutions are available today? It is critical to fit the right solution to each vessel's needs, and in the U.S., there are three primary vessel segments to consider: tugs and towboats, passenger vessels, and ocean-going vessels. Let's begin with ferries, as they've become one of the pioneering vessel types for zero-emission battery deployment. This is because they operate a predictable schedule to just a few ports, meaning batteries can be sized with confidence and only limited shoreside charging infrastructure is required. As an example, ABB is proud to be powering the new Maid of the Mist tour boats in Niagara Falls, which will become the first new-build all-electric vessels in the U.S. when they enter service this spring. The battery banks on these 500-horsepower boats will be recharged in 7 minutes between each voyage. Much larger will be the Washington State Ferries fleet, which operates throughout Puget Sound, as this organization has committed itself to an all-electric future. But what about tugs, towboats, and ocean-going vessels? Well, that too depends on their operating profile. For example, many harbor tugs, inland towboats, and dredgers spend significant time at idle or low load, which is inefficient for the diesel engine. For these vessels, a diesel-electric plant with a battery can help optimize engine efficiency while significantly reducing engine hours. Conversely, for vessels that spend most of their time near full power, like a product tanker, container ship, or line haul towboat, the diesel engine already operates quite efficiently, and so installation of a shaft generator and/or fuel switching to LNG or biofuels may be more appropriate in the near term. But despite these near-term improvements, to get to zero emissions, new technologies like hydrogen fuel cells must be considered. ABB is already working with smaller commercially available fuel cells and is jointly developing a 3-megawatt marine fuel cell with Ballard Power Systems for ocean-going vessels. In France, ABB is proud to be powering what will become the world's first fuel cell-powered towboat. With that, I'd like to close with a few policy opportunities to support the transition to a zero-emission marine future. First, green the federal fleet. The U.S. government is a globally leading ship owner, and as such, it can use its buying power to deploy cost-effective advanced technologies for its own vessels. Two, support financing mechanisms and direct funding for private sector zero-emission vessels. While the total life cycle cost of an electrified vessel can be lower than a diesel mechanical equivalent, the upfront costs are often higher. This investment can still be a challenge for ship owners, and so financial support for early adopters to help build volume will bring down costs long-term for the private sector. Three, invest in research and development. While there are commercially available solutions today for some marine segments, continued technology improvement is needed to serve more challenging vessel applications. I thank you again for the opportunity and look forward to your questions.
Thank you. Ms. Metcalf.
Yes.